Hi, everybody. I am going to talk through um, some proportional reasoning problems. So these problems you're going to see them a lot, and they're always going to ask you a question, something like, if we use 4 times the launch velocity, what will happen to the time the object spends in the air? By what factor will the time in the air change? And usually these problems are things where it's not, well, 4 times the velocity means 4 times in the air. It's not something easy like that. We're always going to try to trick you, and so you need to use your mathematical reasoning to determine if you use 4 times the velocity, how much longer does it spend in the air? Is it 8 times longer? Is it half as long? What is it? But it's not probably going to be 4 times means 4 times. So I like to start with an example, and this is not in your packet, but we're going to write down the givens. So we read this problem, and right away I know they both start from rest. That is important. So anytime you see something like that, they both start from rest, so that means the initial velocity is 0. We know that Josie wins the race because it takes her 7/8 of the time. That's important. You want to write that down. So 7/8 of the time. By what factor is Josie's acceleration bigger compared to Miss Ruta's acceleration? So we're looking at acceleration. That's what we want to know. So right now what we know is initial velocity, acceleration, and time. Well, we have 2 equations that have all 3 of those variables. So what we need to ask ourselves is, do we know anything else about position or final velocity? Because that's the distinguishing factor between the 2 equations that have initial velocity, acceleration, and time. Contextually, we do know something about position. It's a race, and a race means you're traveling the same distance. And so we know something about the position. We know that their change in position is the same. So this is the equation I'm going to pick. Reminder that this delta x, this displacement, just comes from moving x initial to the other side, because then on this side you have x minus x initial, which is the same thing as change in x. Now, once you choose an equation, and you make sure you choose whatever equation has the delta in it, you're now going to start to think about, is anything 0? Can I cancel anything out? Because in proportional reasoning, we cannot do any addition, which you'll see why in a moment, but addition doesn't work with proportional reasoning. If you have a plus sign and you start to, or a minus sign and you start to do proportional reasoning, that is a sign to you that you picked the wrong equation or you have not plugged in zeros yet. You cannot do proportional reasoning with addition and subtraction. You must have an equation that is this equals this. So we know that they both start from rest, and that means the initial velocity is 0, so we can completely cancel that out. Now we have an equation that is something equals something. And the reason why we want that is because we're going to manipulate this equation to determine how much acceleration is going to change if time changes based on this problem. And the way we do that is we just take the equation and we put blanks in front of each of these variables. Now, I even put something in front of 1/2 because that is part of the equation. So what can I fill in here? Here I'm going to fill in factors of change. So what I know is that they both, well, first of all, I know I'm looking for acceleration. That's the most important thing. Put a question mark. That's what I'm looking for. That's my goal. If that's my goal, I must know everything else that needs to go in one of those blanks. I also know 7/8 of the time. And I know that they travel the same displacement because remember, it's a race. So they're going to travel the same distance if they're racing. Now, I also know about this 1/2. What is the factor of change of the 1/2? Is the 1/2 going to change when we switch from Miss Ruta's motion that's described by this equation to Josie's motion, which is described by this equation? No, it is not going to change because the 1/2 is in the equation both times. The 1/2 AT squared is just a part of the equation. It's a constant in the equation. And things that are constant have a factor of change of 1. Think about a recipe, because that's sometimes students will say, a factor of change of something that's constant should be 0. But that's not right, because think about a recipe. If you're going to double a recipe, you would take, every ingredient and multiply whatever the amount is by 2. So if the recipe calls for 2 cups of flour, you're going to double that, you're going to have 4 cups of flour. Well, to keep the recipe the same, you wouldn't do 0 times 2 cups of flour. You would do 1 times 2 cups of flour. So that recipe needs to stay the same. So 1 means a constant. It's the same for both people. Now I'm going to pull each of those numbers, each of those blanks out, and I'm left with this. So this is now just factor math. Now something I want to point out to you is that this 7/8 gets squared. And that's because this 7/8 is not 7/8 times t squared. It's 7/8 times time. That's what is given to us. It's 7/8 of the time. But time in this equation is squared. So you almost could put parentheses around here to remind yourself, like, we're saying it's 7/8 times the time. So then it has to be squared. We do some algebra, and we learn that Miss Ruta, or Josie, has 1.3 times the acceleration of Miss Ruta. All right, we're going to do this next one. So a train accelerates at a rate that is half of that of a car. So I need an acceleration equation. A train's maximum speed is 2 times bigger than the maximum speed of a car. So that's max speed. They're starting from rest, so max speed would be their final speed. And they both start from rest, so that's initial velocity. So I'm looking for an equation right now that has acceleration, max speed, so final velocity and initial velocity. So I have 2 with that. But my question mark is which one travels farther. So I need to know I need to use the equation with displacement in it. So this one. First step, plug in any zeros. So I know that the object is starting at rest, so this whole term just goes away. I have an equation that's something equals something, so I'm ready to start. I'm going to put those blanks in front of each piece of my equation, and I'm going to start to match information. First of all, I'm looking for displacement, so I can put that in as my question mark. Then the other number that I'm given is that the train is accelerating at half the rate, so I can put that in for acceleration. And then I also know that the train's maximum speed is 2 times bigger. So that goes in front of the 2v. And then just like that 1/2 in the 1/2 AT squared equation, this 2 is always going to be in the equation. This equation just has that 2 in there no matter what. And so that 2 is a constant in the equation. And so we are going to call that factor of change of that 2 1. that 2 is not going to change. So from here, I'm going to pull those numbers out, pull those numbers in the blanks out. Remember, v is squared, and so that means the factor needs to be squared too. And I'm going to start to do some algebra. So the factor of change is 8, which is the factor of change of the displacement. So the train travels farther than the car by 8 times. Now, these are 2 examples of problems, and I think oftentimes examples are what's most helpful for students in learning proportional reasoning. But I will also put this up on the screen if you want to screenshot it, or if you'd like to, copy it down in your packet if you like lists. But this is the information that this is the procedural way to proportionally reason.